Hello everybody, it's Amell, and today I'm going to teach you how to solve the jewels and stones problem. You're given strings J representing the types of stones that are jewels, and S representing the stones that you have. Each character in S is a type of stone you have. You want to know how many of the stones you have are also jewels. The letters in J are guaranteed distinct, and all characters in J and S are letters. Letters are case sensitive, so lowercase a is considered a different type of stone from capital A. Here they give you two examples. Example 1, the input is the jewels A, capital A, and the stones that you have. So the output is 3. Why? Because if you examine the stones that you have, you only have these 3. Because you know that the only stones that are jewels are lowercase a and capital A. So you have these 3 jewels. The method returns 3. In example 2, the only jewel is lowercase z, and what you have is capital Z, capital Z. So you don't have any jewel, so you return 0. How can we solve this problem? The brute force approach is to use 2 nested for loops. And then for every character in the stones that you have, you check if that character is actually a jewel. You check if that stone is a jewel. The time complexity is going to be big O of m times n, where m is the length of J and n is the length of S. The space complexity is big O of 1, and that would be the brute force approach. But we can actually improve the time complexity if we use extra space. If we use a data structure like a set, then we can find an element in constant time. So the time complexity using a set would be big O of m plus n, and the space complexity would also be big O of m plus n. So in this video, I will show you both solutions. First, I'm going to show you the brute force approach, and then I will show you the approach using a set data structure. So without further ado, I'm going to show you the brute force approach. First, I'm going to have integer result case of value 0. That's the final result that tells me how many jewels I have, and then I will examine all the stones. So for integer I case of value 0, I is less than capital S dot length plus I. Then for every stone, I will check if it is a jewel. So for integer J case of value 0, J is less than capital J dot length plus J. Then if capital S dot char at I equals capital J dot char at J, then I know that the stone that I'm examining now is a jewel, so I can increment the count. I have one more jewel, and then I break. Why do I break? Because I'm searching the jewels, and as soon as I find that this stone is a jewel, I stop searching in the jewels string. So at the end, I return the final result, which is the number of stones that I have that are jewels, or the number of jewels that I have. I run the code. I will submit a solution. This is working perfectly. So as I said, the time complexity for this solution is big O of m times n, and the space complexity is big O of 1. And this is the brute force solution. Now I will reset the code because I will show you a solution that takes big O of m plus n time, which is better time complexity. So first I'm going to have integer result case of value of 0 to tell me the number of jewels that I have. Then I will have a set of character set case of value of new hash set. Then I will put all the jewels in the set. That way I can check in constant time if I have a jewel. So for char j in capital J dot to char array set that add j. So I put all the jewels in a set. Now I can examine all the stones from left to right. So for char s in capital S that to char array And then I check if this stone is a jewel. So if set that contains this stone, I will say plus plus result. That way I know that I have one more jewel. I increment the final result, and at the end I just return the final result. I will run the code. Alright, I will submit the solution. This is working perfectly. So as you can see, the time complexity is big O n plus n, which is better than the time complexity of the brute force approach. The space complexity is also big O n plus n. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.